Hello, Las Vegas! Today we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end-to-end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself, where we human drive it, driven using human demonstration. And we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. And so, but every single car will have autonomous vehicle capability. Every single car will be AI-powered. And so the model layer in this case is Alpamayo, and the application above that is the Mercedes-Benz. Okay, and so this entire stack is our first NVIDIA first entire stack endeavor. And we've been working on it for this entire time, and I'm just so happy that the first AV car from NVIDIA is going to be on the road in Q1, and then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4. And the powerful thing is that we're going to keep on updating it with next versions of Alpamayo and versions after that. This car just got rated. It just went to production. The Mercedes-Benz CLA was just rated by NCAP, the world's safest car. It is the only system that I know that has every single line of code, the chip, the system, every line of code, safety certified. The entire model system is based on sensors are diverse and redundant, and so is the self-driving car stack. The Alpamayo stack is trained end-to-end and has incredible skills. However, nobody knows until you drive it forever that it's going to be perfectly safe. And so the way we guardrail that is with another software stack, an entire AV stack underneath. That entire AV stack is built to be fully traceable. And it's taken us some 5 years to build that, some 6, 7 years actually, to build that second stack. These two software stacks are mirroring each other. And then we have a policy and safety evaluator decide, is this something that I'm very confident and can reason about driving very safely? If so, I'm going to have Alpamayo do it. If it's a circumstance that I'm not very confident in, and the safety policy evaluator decides that we're going to go back to a simpler, safer guardrail system, then it goes back to the classical AV stack. We're the only car in the world with both of these AV stacks running, and all safety systems should have diversity and redundancy. Hurry up. I got a lot of stuff to cover. Come on. Hurry. Did you tell R2-D2 you're going to be here? Did you? And C-3PO? And today we're announcing that Siemens is also doing the same thing. We're going to integrate CUDA-X, physical AI, agentic AI, Nemo, Nemotron, deeply integrated into the world of Siemens. And the reason for that is this. First, we designed the chips, and all of it in the future will be accelerated by NVIDIA. You're going to be very happy about that. We're going to have agentic chip designers and system designers working with us, helping us do design, just as we have agentic software engineers helping our software engineers code today. And so we'll have agentic chip designers and system designers. We're going to create you inside this. But then we have to build you. We have to build the plants, the factories that manufacture you. We have to design the manufacturing lines that assemble all of you. And these manufacturing plants are going to be essentially gigantic robots. Incredible, isn't that right? I know. And so Vera Rubin is the person that we named our next computer after. Isn't that a good idea? I know. Okay, Vera Rubin is designed to address this fundamental challenge that we have. The amount of computation necessary for AI is skyrocketing. And if Vera Rubin is going to be in time for this year, it must be in production by now. And so today, I can tell you that Vera Rubin is in full production. This is a Rubin pod, 1,152 GPUs in 16 racks. Each one of the racks, as you know, has 72 Vera Rubin, or 72 Rubins. Each one of the Rubins is 2 actual GPU dies connected together. I'm going to show it to you. The Vera CPU, I'm so proud of it. In a power-constrained world, Grace CPU is 2 times the performance. In a power-constrained world, it's twice the performance per watt of the world's most advanced CPUs. Its data rate is insane. It was designed to process supercomputers. And Vera was an incredible GPU. Grace was an incredible GPU. Now Vera increases the single-threaded performance, increases the capacity of the memory, increases everything just dramatically. It's a giant chip. This is the Vera CPU. This is one CPU. And this is connected to the Rubin GPU. Look at that thing. It's a giant chip. We now have a new processor called Bluefield 4. Bluefield 4 allows us to take a very large data center, isolate different parts of it so that different users could use different parts of it, make sure that everything could be virtualized if they decide to be virtualized. So you offload a lot of the virtualization software, the security software, the networking software for your north-south traffic. And so Bluefield 4 comes standard with every single one of these compute nodes. We decided that we would create an industry standard system so that the entire ecosystem, all of our supply chain, could standardize on these components. There are some 80,000 different components that make up these MGX systems, and it's a total waste if we were to change it every single year. Every single major computer company, from Foxconn to Quanta to Wistron, the list goes on and on and on, to HP and Dell and Lenovo, everybody knows how to build these systems. And so the fact that we could squeeze Vera Rubin into this, even though the performance is so much higher, and very importantly, the power is twice as high. The power of Vera Rubin is twice as high as Grace Blackwell. And yet, and this is the miracle, the air that goes into it, the air flow is about the same. And very importantly, the water that goes into it is the same temperature, 45 degrees C. With 45 degrees C, no water chillers are necessary for data centers. We're basically cooling this supercomputer with hot water. This is the world's first manufacturing chip using TSMC's new process that we co-innovated called COUP. It's a integrated silicon photonics process technology. And this allows us to take silicon photonics directly right to the chip. And this is 512 ports at 200 gigabits per second.